there. Okay, so today we're talking all things linear. And I know in your mind you're thinking, oh, okay, this is going to be an easy one. All right, so I am going to throw in some new things that are linear that maybe aren't something you've always done with linear functions, but we do have some of that repeat linear stuff to make it a little bit easier. I'm going to start off and just talk through some formulas, jot them down, and fly through this part. All right, so first of all, you need to know how to find the slope. The slope formula is m equals, and then you do y minus y over x minus x. Now, so of course you need to know two ordered pairs to be able to do your slope formula. A little extra thing about slope, parallel lines always have the same slope, while perpendicular lines have opposite reciprocal slope. All right, now, if you're going to write the equation of the line, and we are, there's actually three different forms of that line that you could write. We're going to jot a few of those formulas down. Point slope form works great if you're trying to write the equation of a line and you know a point and the slope, okay, which oftentimes we do. So point slope form looks like this. And I don't get too caught up on the ones and the twos and the bases. I just know in my head, I just got to be consistent always when I do that. So ultimately, I'm just doing y minus y. And honestly, I don't know if you realize that point slope form is just a rearrangement of the slope formula. If you multiplied both sides by the denominator, you would have it. But really, this is used a lot in calculus. And so we try to prioritize this version over the next one that we're going to talk about, which is the one you're more familiar with probably, is slope-intercept form. Slope-intercept form is a really good form because it identifies, just by looking at it, your slope and also your y-intercept, and those both have meaning in the problem that you're working on. So we will use those two methods the most. All right, HOIVUX is just a little acronym. Your teacher may or may not have used HOIVUX. I like it as just a little acronym to remember the easy lines. I say they're easy, but sometimes they're so easy that they're different, and then that makes them harder. But ultimately, what this HOIVUX acronym is telling you is that horizontal lines, notice the H, have zero slope. Notice the O there, that's a zero slope. And if you're going to write the equation of a horizontal line, it's always going to be a y equals some number, like y equals 3. And then that's a horizontal line at 3. But it only has a y in it, it doesn't have an x. Okay, so that's where your HOI comes from. And probably from that, I'm betting you could come up with what the VUX stands for. So V is vertical. Lines have undefined slope. And their equations are always just an x equals some number. There is no y in their equation. All right, so that's sort of your basics. That was the stuff I promised. Okay, there's going to be some easy stuff. There it is. All right, couple more formulas that you'll need to know. I'm not doing examples. I'm just writing the formulas so that it's here handy for you when you need it. The distance formula, again, given 2 points, you're going to do the square root x minus x squared plus y minus y squared. Doesn't matter which x you start with, as long as whatever you decide, you start with that same point when you do your y's. Midpoint, this one's a little bit different. I always think of the midpoint, it's sort of just like the average. If you had a couple points, one's down here and one's over here, let's say, and I want to find the middle of those, ultimately what I'm doing is I'm finding the average of them. I have to find the average both horizontally, but also the average vertically, and it would land me right here. So what I'm going to do is with these two ordered pairs, I'm going to find the average of the x values, which means just add the x's, divide by 2, and then find the average of the y's. Add the y's, divide by 2. This formula people mess up because they like to put a minus sign right here. because distance uses a minus, slope formula uses a minus, but midpoint is a plus sign. That's why I try to think of it like an average, because I know in my head to average things, I add them and divide by how many there are. All right, more easy stuff. All right, let's go on to something maybe harder. Let's see. I don't know if this is hard or not, but it is using those formulas right there. So when we're doing this, well, I'll take a minute to read it here. It says write the equation of a line perpendicular to the line passing through these 2 points and has an x-intercept of 6. All right, so to write the equation, I'm usually going to use point slope form, but I don't have the slope. I can find it. I'm just going to do my slope formula. Make sure that you're getting your y's on top. And it didn't matter which point I started with there as long as I stayed consistent. So this is actually going to reduce to a slope of 3/4. Okay, so that was the first test. Did you know how to find the slope? Next test is, oh wait, I want it to be perpendicular to this line. So it's not going to have a slope of 3/4. The slope I'm going to have to use is the opposite reciprocal. So really, that's what I'm going to want for my slope. And sometimes I can just use one of those points, but they're giving me some specific information here. So this is a little bit different probably than you've done before. They're telling me what the x-intercept is. All right, well, there's different things they can do, and that's just a fancy way of ultimately telling you another point. If you have an x-intercept, of 6 over here, that's really just an ordered pair, 6, 0. So what I do have is a point and the slope. So I have what I need to put it into point slope form. So here we go, y minus the y in my point. So I might have just written a y, that'd be fine, equals m times x minus the x in my point. So I'm going to have a y equals, distribute the -4/3. I just like to think of this as a 6 over 1. And then I do negative times a negative. That's going to be a plus. And you multiply fractions straight across. So I'm going to be taking this -4 times this -6, and this 3 times this 1. So that's going to be a 24 over 3. That's 8. And I've got my equation. I'm done. Now, when we talk about slope, it's really just an indication of what we call the rate of change. How quickly is something changing? And what makes linear functions special is they're the only ones that have a rate of change that is constant. We don't even talk about the slope in other graphs because they don't have a constant slope. On a parabola, the slope gets steeper the closer around. Here, let me sketch what I mean. If this is a parabola, the slope of this gets steeper and steeper and steeper as I go. So it doesn't stay constant. We don't use that term slope with a parabola. Linear equations are the ones that we talk about, the slope. Now, I say that it stays constant, but it's not always constant. So here's a situation. We actually did this problem on day 1 when you had a partner and you had to like sketch a graph of the situation, and it was somebody's age or their height over their lifetime. All right, so this doesn't go that long. It's only from ages 0 to 20. But I think we had kind of decided that by the time you hit 20, you kind of have hit your height until you get really old and you start to hunch over. But you can see that this does not follow an exact linear path. So what we're going to do is find what the average slope is over a certain length of time. It changes. So you can see when you're born, here we are kind of having a growth spurt early on, but no, wait, really steep growth spurt right here between 3 and 4 years old. You get really tall, and then it kind of levels out as you're growing up. But then typically in your teen years, you start to have growth spurts and you get a little bit taller there. And so what we're going to do is just find the average rate of change over a certain time frame. So their example here is they're picking when they're 13, to when they're 18, what is that average rate of change? Well, what that would do is actually ignore the fact that it's really steep here and less steep here, and it's just going to do an average over that time frame by grabbing this point and doing the slope. And it creates what we call this secant line. Secant is a line that cuts through a curve, and it kind of just tells you your average over that time frame. All right, so we're going to do something like that. I'm actually going to do it with a parabola. So here I'm just going to do the basic parent graph of a parabola. And I'm going to pick two spots on this parabola, and we're going to find the average rate of change. We've already talked about how it's not going to be constant, so we just find an average over a certain range. So from 0 to 1, we want to know what that rate of change is. All right, so what I'm going to do is I'm going to set it up like this. I'm going to say f of 0. So if I put 0 in for x into my function, I'm going to get 0 back because 0 squared is 0. If I were to plug the 1 in, 1 squared is 1. So what I have here are two ordered pairs. I'm going to write them this time, but futuristically, we just want to recognize that this right here is equivalent to these two ordered pairs. And then I'm just going to do the slope between those 2 points. So I'm going to do a y minus y over x minus x. Okay, the slope or the average rate of change, I'm going to write it here. The average rate of change, that's going to be my notation there, is going to equal 1 over that span of x values. Okay, let's try again. This time I'm going to do it over a different span of that parabola. So if I put 1 in, 1 squared is 1. If I put 2 in, 2 squared is 4. So now when I do y minus y, I'm going to have 4 minus 1 over 2 minus 1. And my slope is now 3 over 1. So the average rate of change is equal to 3. Now that's steeper. So that stretch of the parabola is steeper than what the first one was. All right, now I'm going to turn you loose. Can you do f of negative 2 and f of 0 and then find the rate of change? Okay, hopefully you got a negative 2 on that. The fact that the rate of change is negative would indicate that you are kind of declining at that point of the graph. All right, so I'm going to go ahead and go to the next slide, and we're going to actually look at these same 3 scenarios graphically. The first point, we went just from 0 to 1. So this ended up being the slope. From here to here, that was your slope. Then I scooted it over and I went from 1 to 2. You might notice here that this is scaled by 2s, but it's a much steeper situation. We ended up, this had a slope of 1, this was a slope of 2. It got steeper. If you look at the third scenario, we actually came from negative 2 to 0, and at that point we were headed back downward, so that's why our slope was negative. All right, so I kind of want you to understand what's happening on that graph and what it is that you're really finding. This is all a precursor to calculus, which we will hit on again towards the end of this course, this whole idea of finding that slope. Just a little tease, I guess, for what's coming. All right, so let's see if we can do an application where we have to take these words and turn them into an equation. So we're doing linear depreciation. So it looks like the college bought some exercise equipment. It was $12,000. The equipment could be used for 8 years. And then the salvage value, I guess they're going to go sell it. They can get $2,000 for it at that point. So we want to write a linear equation that describes the book value of the equipment each year. What you're going to do is you're going to take the info they gave you and turn them into ordered pairs. And we have to look at what are the variables involved here. And it would appear that we have value of the equipment. That would be one of them. And how long they've had it, which ultimately is time. And if you think if those are going to be your two variables, which one of those is independent? I hope you're thinking time. So we would write these ordered pairs as time as your X value, and then the value of the equipment is like your Y. And let's see if we can come up with a couple ordered pairs then from the info. All right, well, when they first bought it at time 0, the value was $12,000. And then 8 years later, so that's time 8, the value is $2,000. So then what they want us to do is take these 2 points and go write the equation of that equipment. So I'm going to have you pause the video. You go write the linear equation on that. Okay, so here's what my equation ended up being when I did it. And you can, this is not what you got, then you should pause the video and go look and see where you might have gone wrong. I did take advantage of the fact that this ultimately right here over 0 up 12,000, that is the y-intercept. So I didn't really even have to go do point slope form. I just found the slope and the y-intercept and I just put them in place. All right, so next question is to interpolate the value of the equipment after 5 years. So interpolate means to look inside of the data, the information that you have to predict something. Extrapolate is what it means to like predict into the future. So this one, since 5 years is within our 8-year range, this is called interpolating. Plus it's fun to say. Okay, so here we go. 5 years, all I'm going to do is take 5 and put it in for the t. So negative, and I should have already done this. So negative 1250 times 5, and then add your 12,000, and we end up at the value is $5,750. So in that case, you just have to type it in or plug it in. Okay, so the next question, this one's important. Interpret the slope. This is kind of the next level type of questions that I'm going to ask a lot in pre-calc is, do you understand what you just found, or you just plugging and chugging through numbers? Interpret the slope doesn't mean tell me the slope. It tells me what does it mean in this problem. So I'm going to kind of go through and explain this because we kind of do this interpreting a lot. I want it to make sense for you. When you see that the slope is negative 1250, I think of it as over 1 because I'd like it to be a fraction because ultimately slope is rise over run. The rise are your y's, the run are your x's. And if you look at what we decided right here, the y's are actually the value, while the x's are your time. So what this means to me here is that if I let 1 year go by, then the value is going to decline $1,250. That's what that slope means. And if you turn this into a fraction, you can always see how that plays out. I like to write this as a sentence. So for every year, and you can say 1 year, but I think it makes sense, just say for every year, the equipment, and you can use all kinds of words here. I kind of like the word depreciates. $1,250. So this is what I'd be shooting for. Sorry, that got a little bit messy here. That's what I would be shooting for on and interpreting the slope. All right, so ultimately we're kind of done with linear stuff. I want to do a little preview for tomorrow because tomorrow is kind of a long day and we have a little bit more time today. So just a few things algebraically getting us ready for tomorrow. Tomorrow is going to be on quadratics, and we have just some efficiencies, I guess, as much as anything. So I'm wondering how many of you, if I gave you an x plus 5 squared, that you would write x plus 5 out twice and then FOIL it. And then combine that together. Raise your hand if that's you. Okay, I can't see you. It doesn't matter. Okay, here we go. So what I would like to do is be able to get from here to here with all that, without all of that work. So let's look at what happened here and what's going to happen every single time you do this. Every single time, this first term is going to come from you multiplying the firsts. And the firsts are always going to be the same. So it's really just taking this number and squaring it. This number always comes from doing the last, same concept. Really, all you're doing is taking this number and squaring it. Now, the number one thing you don't get to do, I didn't even offer this as an option, you cannot take this squared and just distribute it. Distributing is what you do with multiplication. This is a power. Cannot do that. You can see that you actually end up with this middle term in here. That happens every time. That middle term is coming from the outer and the inner. The outer and the inner will always be you multiplying these two values together, and you'll always end up doing it twice. So it always gets doubled. So really all I have to do is take these two times each other and then double it, and I'll have it. Okay, let's try it. Here we go. I'm just going to jump right in. First term, I'm going to square the 2x. So that's a 4x squared. My middle term is going to come from multiplying these two together and then doubling it. So that's going to be a negative 2x. Doubled is a negative 4x. And then your last term comes from squaring the negative 1. That's always going to be a positive because you square it. All right, simple as that. All right, why don't you pause the video for a moment and try this last one on your own. Okay, so here's what I've got. Just trying that shortcut. Again, just an inefficiency. We're going to have long enough problems that the things that we can do mentally that we've been doing for years, we should be doing them. Okay, here's my next little efficiency that I want to talk about. This right here, where you take a binomial and you're going to square it to say it, and then it equals a number. You have some options here in what you can do. Some people might go do their, well, hopefully now they're going to do their shortcut. And they're going to square this, and then they get this right here. And then they'll bring the 16 over and then refactor it. That works. It is not efficient. And a more efficient option would be just to square root both sides. Here's the problem with this method, is that so many people forget a key part of this. This is a quadratic. You should have two answers. Your two answers come from putting a plus or minus on that. When you square root both sides, you must have that plus or minus. And then you're just going to subtract the 5 to the other side. So if the if the 4 was positive and you subtracted the 5, you'd get a negative 1. But if the 4 was negative and you subtracted the 5, you'd get a negative 9. All right, so I started with one that was pretty straightforward. Let's look at this next example, not quite as nice. In this case, the whole idea of square rooting both sides can't happen until you've isolated this squared term. So the very first thing I want to do is add the 3 over. That would get me a 10. And then I want to divide by that 2. So that would get me a 5. So my first step is to isolate it. Now I'm going to go ahead and do my square root of both sides, not forget the plus or minus. Now this doesn't come out near as nice. So that's okay, we just leave it as a radical. I'm going to add the 1 to the other side. I like to put that on the front end of that. And these are your two solutions then. All right, I got one more page. Let's talk about factoring. Factoring is one of those things that, I don't know, there's about 4 different ways out there to factor. Who knows the different ways you've learned, because you do this first time in Algebra 1, you do it again a little bit in geometry, you do it a lot more in Algebra 2, and so you've had different teachers. I don't know how you do it. here's the thing, is I'm not going to show it 4 different ways. I'm going to show it one way. I sort of feel like at this level that we should be using some number sense. We're pretty smart kids. That's why we're in pre-calc. We can do this. So instead of taking 4 steps of whatever trick you have to do this factoring, ultimately what I'm going to do is I know that the 8x squared came from multiplying the first. So I got to pick 2 numbers that multiply to 8. I could do 8 and 1. I could do 4 and 2. I'm kind of going through this, but really you'll do this kind of stuff in your head. Factors of 90 are what come from getting the multiplying the last. So that could be a 9 and 10, or any number of other things, maybe a 3 and a 30, or a 15 and a 6. There's so many options here this could be. So I want to use kind of common sense to come up with it. What you want to do is you want to look at this sign right here. If that's a plus sign, then you know that these 2 terms have to be the same sign. So you will have both pluses or both minuses. Since we are looking to get a positive 89, that's going to force them to both be pluses. So I'm going to put a plus here and a plus here. That also means that when you do your outer and your inner, that's going to get you this 89. You are trying to build these up big enough so that you're up to an 89. 89 is kind of extreme. We're going to have to use some kind of big numbers multiplied to get up that high. So these 2 outer and inner have to add up to an 89. And I'm just thinking, if I did the 9 and 10, that's what jumps out at me. I could end up with a 40 and an 18, and those aren't going to get me near high enough. So I'm leaning towards this 8 and 1. So I'm going to try it. Here's the thing. We do this guess and check game, and if it doesn't work, we erase it and try again. The thing is, though, is we get pretty good at doing it in our head. All right, so I'm going to do the 9 and 10. So I could put the 9 here and the 10 here. Let's see what that gets us. That's a 72 and a 10. That's 82. Not what I want. I want an 89. So what I do is I swap those. And if you can think about it before you write it, you save yourself some eraser. But there's your 80 and 9. There's your 89 that you want. Now, I know that that took me a while to do. I'm trying to teach a thought process, which is kind of tricky sometimes. Really, you're thinking through all of those things in your head before you ever write. Let's try it one more time. This time, I've got a minus sign here. That means that these 2 will have to be different signs, which means that the outer and the inner will end up subtracting to a 9. So what I'm going to have to do is I'm going to have to get something that's bigger than 9 and something smaller than 9, so that when it subtracts, it ends up at 9. So, and I take that back. It doesn't always have to be, but I do need to end up with something bigger than 9 so that when I subtract, I can get it down to 9. So I don't know. We can try 3 and 3. We could try 9 and 1. I got to think this is probably a 4 and a 7. Let's throw that in there. If I go 9 and 1, I feel like that's going to get pretty big. Like if I put my 9 here, that would be a 36 and a 7. That's too much of a broad range. So I'm going to go with my 3 and 3, and I'm going to see what happens here. All right, so then I have a 12 and a 21. So 21 minus 12, what do you know? That's 9. I do want my 9 to be negative, so I want my 21 to be negative and my 12 to be positive. And I've got it. This is really good, a really, really good way to practice mental math. I know some of us get pretty caught up in using our calculator every single time, but you gotta exercise that brain. All right, this next one, it's still just a trinomial, but what I want you to notice on it is that this happens to be a perfect square, and so does that. So it's pretty likely that this might end up being a perfect square trinomial, which means that when you set these up, instead of guessing and checking through it, I'm just going to use the fact that that's a perfect square and just use its square roots. And the 49 would be a 7 and a 7. Notice that it's a plus 49, so the signs are the same. They're both going to be minuses. And what happens here, now that after I'm done, well, I should check this. I'm sorry. There's a negative 14 and another negative 14. Yep, that checks. But notice that the two quantities are the same. That's how a perfect square trinomial will factor. So we will write it 2x minus 7 squared. This is actually the idea where completing the square comes from. All right, and then this last one, my thing that I want to remind you of here is that you would always want to look for a GCF to make your life easier, get those numbers smaller. I'm going to pull out, looks like I can pull out a 4 on this. So then I have a 6p squared. All right, now I leave the 4 hanging out there. Set this up. I don't have options, 3 and 1. Got to be 3 and 1. It is going to be a positive and a negative sign. So now I'm going to try to get something, build something up bigger than 7 so that when I subtract it back down, I end up at 7. If I put a 6 in this first slot, that gets me to an 18 and a 1. That's way too big. So I don't think I want that. I'm probably more inclined to do a 2 or 3. So think about it with me. If I do a 2 here, that's a 6, 3. Not a difference of 7. What if I put a 3 here? That'd be a 9 and a 2 here, 9 and 2. There it is. That's what you're doing. You're thinking before you're writing. So I'm going to put my 3p and my 2p. That's a 9p and a 2p. I want a positive 7, so I want my 9 to be positive and my 2 to be negative, and I've got it. Okay, so that idea of factoring that I know you've done since Algebra 1, we're going to be using that a little bit tomorrow. Thought we would practice it today. All right, thanks for hanging with me. Go do your homework.